The speed of sound wave in air is 343 meters per second, which is approximately 770 miles per hour. So we're going to use that to do some quick calculation for us. For example, let's say we have a wishing well here. There's water on the bottom of it. And you stand here holding a coin in your hand and you drop it in the water. The distance from where you're holding the coin to the edge of the water is 7.35 meters. The question is how long it will take you to hear the splash. Well, when you think about the time, how long it's going to take you, the time actually is going to be the time for that coin to go all the way to the water, plus the time is going to take the coin, or the sound, once the coin hit the water, the sound to travel back to your ear. So let's find each one of these, go through them, add them together, and that's the answer we're looking for. So now the time to travel up is going to be the distance divided by the velocity. Now the coin is not going to go up, but the sound, sound wave, once that coin hits the water, is going to make a sound wave that's going to travel through the air to your ear. Well, we know the distance, which is 7.35, and we know the velocity of sound or wave in air is 343. You divide the two numbers, and that will give us 0.21 second. Next, we need to know what is the time to travel down. Well, for the coin to hit the water, that's free fall. So we have to go back to physics 1 and apply what we know. If I use the water as reference, I know the initial height is actually 7.35. I know the final height was 0. I know the acceleration is gravity, negative 9.8 meters per second squared. I know the initial velocity is 0. I released it. I didn't throw it in. And the question, can I find the time? And the equation I'm going to be using here, y equals y sub 0 plus v0t plus 1/2 at squared. V0 is 0 times anything is 0. 1/2 times negative 9.8, that's negative 4.9 t squared. So 4.9 t squared equals 7.35. T squared equals 1.5, or t will equal 1.22 seconds, the square root of that. So the time to hear the sound is going to be the time to travel down, add to it the time for that sound wave to travel back up to me. That's 1.22 plus the answer from the previous one, which is 0.021, and that's going to equal to 1.24 seconds. So it's going to take 1.24 seconds for us to hear that sound. While we're at it, let's talk about sound intensity. Well, intensity here, or sound intensity, we define that as the amount of energy passes through a given area in a given time. So notice it includes given area and given time. So intensity is the energy divided by the area times the time. Well, we know power equals energy divided by time. So intensity also can be written as power divided by area. So if you have a loudspeaker, that puts out a 0.15 watts of sound, through a 2 meter squared area, what is the intensity? Intensity is power over area. The power is 0.15. The area is 2.075 watts per meter squared. If the area gets bigger, let's say 4, this will be half of this number. If the area becomes smaller, let's say 1, this number will increase the intensity. So as the area increases, the intensity decreases. As the area decreases, the intensity increases.